Good afternoon. Today we are starting with the experiment number 7, that is the study of the digital storage oscilloscope. So if you look at the ordinary CRO, we have so many types of the CROs are available. So when we add the A to D converter with the ordinary CRO, then we can convert the ordinary CRO into the digital storage oscilloscope. Right. So here we have certain changes that if we want to use the high-speed A to D converter, so number of comparators will increase with the number of bits. For example, a 3-bit A to D converter, flash type of 3-bit A to D converter will always require 2 to the power 3 minus 1 equals 2 to the power 3 minus 1 equals 7 comparators, right? So if you increase the bits like 5 bits, so in that case 2 to the power 5 minus 1 equals 31 comparators are required. So this is the wastage of the money, and increase in the size as well as the complexity will increase. So in that case we cannot use high speed A to D converters like the flash type of A to D converters. So what we can do, the solution is that we can use the low cost A to D converters in digital storage oscilloscope. So for that purpose, we have continuous type of A to D converter, counter or ramp type of A to D converter, single slope A to D converter, dual slope A to D converter, successive approximation A to D converter. So if you look at the new section in the DSO in comparison with the CRO, so we have a switch named as a stored. Then the second is a dot joining. Third one is a single. So that switch is available here single. And fourth one is a hold for the channel 1 and for the channel 2, right? As well as this can be reset with the help of the reset switch. So whenever you want to observe any signal, in that case you have to first pass the signal through the store, right? So store will convert the signal into A to D, and that have the capability of variation in the frequency and the amplitude with respect to the control switches of the function generator. This signal that you pass through the store, that signal is then passed through the single, right? And that can be held in the channel 1 or the channel 2 depending on which channel you are selecting here. Both the signals can be observed with the help of the dual if the two signals are stored in hold 1 and the hold 2. The question is that why we are requiring the two switches, one is a store and other is a hold. So the answer is that when you are using the high speed or flash type of A to D converter, so in that case the resolution will be better, right? But because of the increase in the comparators, because of the reduction in the bandwidth, we cannot use high speed A to D converter, so we have to go through the low cost A to D converter. So in that case the signal cannot be directly applied to the slow A to D converters, so that first signal is passed through the analog storage and then that is passed through the multiplexer. So multiplexer is a representation of the signal here. Then the signal is held in the storage, right, for channel 1 and the channel 2. We have also written the procedure here that how to work with the digital storage oscilloscope. So press the signal, pass the signal through the storage switch, then pass the signal through the switch named single, then store the A to D converted signal using the switch named hold for channel 1 or channel 2. If two different signals are A to D converted and is stored using hold 1 and hold 2, then by pressing the dual switch, both the signals can be observed on the CRO screen. And if you want to remove the signal from the hold 1 or hold 2, so in that case you can press stored switch. That means the signal our signals will be released from the hold 1 and hold 2. After pressing the storage switch, we can restore the waveforms or pass the waveforms to the single. That is the indication of the multiplexer. So after releasing the storage switch, DSO can be converted into the ordinary CRO. When you want to observe the two signals, so you have to use dual switch, right? So 2-channel DSO can be converted into the observation or the analysis of the 4 waveforms. Means the 2 signals can be stored using the hold 1 and the hold 2, and after releasing the switch storage, we can use our DSO in ordinary CRO mode. So we have started with the sinusoidal waveform. So let us observe the sinusoidal waveform on the DSO screen. You can observe here that the waveform is continuous, right? You can look at the waveform here, that this signal that we have applied to the channel 1, right? This is continuous here. Okay. So this waveform we want to convert in the digital form, right? So we have to use digital storage oscilloscope, and then we want to store the signal. So that's why what we are doing here, we are pressing the switch named store, right? So when I press the switch named store, what will happen here, that the signal will be converted into A to D form. So how we can verify that the signal has been converted into the A to D form? So for that purpose, let us use volts per division switch. So now you can find on the screen that the signal has been converted into the samples, right? So for the conversion of the signal in the digital form, we have to follow the Nyquist criteria, that the sampling frequency should be minimum of the twice of the signal frequency. So on the basis of this one, we use sampler,